everyone, it's Mrs. Suderman, and this is a video of solving systems of linear inequalities, which you can see in your textbook of Chapter 3, Section 3. When a problem uses phrases like greater than or no more than, you can model the situation using a system of linear inequalities. Up until now, the systems that we have looked at have just been equations with equal signs, but the systems that we're going to be looking at now are going to be inequalities. So you have greater than or less than, or equal to, greater than or equal to, that kind of thing. And so instead of looking at where these lines intersect at a point, we're going to be looking at regions that are intersecting, in other words, that are shaded and overlapped. We'll look at a couple of examples here in just 1 second. So here's this system. Y is less than 1/2 x minus 3, and y is greater than or equal to negative x plus 2. So we're going to graph the system of inequalities, which will really help you see what this solution will look like. So the first thing we need to do is graph the first equation. So the equation for this line, if we were just looking at for the line for 1 second, would be 1/2 x minus 3. The y-intercept is negative 3, so that's why, here, let me get this right here. So since it's at negative 3, that's our y-intercept. We put a point at negative 3, and then our slope is 1/2, so we go up 1 over 2, up 1 over 2. And then you'll notice that in this picture here, it's a dashed line. That is because this inequality, it is a less than, it doesn't have the equal to. So since it does not have the equal to, we will just do a dashed line. And we're going to shade below because we're saying where are the y values less than this line 1/2 x minus 3. So underneath it is where the region needs to be shaded, where the y values are less than the line. Okay? We also need to graph the other inequality, y is greater than or equal to negative x plus 2. Same thing. We have the y-intercept of 2. So we put a point at 2, and this time our slope is negative 1, so we're going to go down 1 over 1, down 1 over 1. And you'll see that this line is solid because it's a greater than or equal to. That equal to makes this a solid line. For this portion, we're going to shade where y is greater than or equal to the line, which is this yellow region here. So all of the y values are greater than the line above this, so this yellow region. Now the solution for these for this system is where the two regions that have been shaded, they overlap. So you'll see that it's this part over here. To test a point from each region could be a really helpful thing. If we looked at the graph of that, there were 4 different sections, right? Here, let me go back and show you. We have above it, so this would be above, this would be the left, this would be the right, and this would be underneath or the bottom. So if we test a point from each of these areas, then we should be able to plug them in to both of our inequalities, and whenever both are true, which you see here, whenever we plug in this point 5, negative 2, which was from the shaded region, when we plug that in for the x and the y into both of the inequalities, just like how we verified solutions in systems of linear equalities, it should be true. So you see there's a check mark there, check mark there. It works for both of the inequalities. Therefore, we did a good job of verifying our solution. We did a good job of shading our graph. We've got the correct answer. By the way, if you're unsure of which direction to shade, use the origin as a test point. Origin is 0, 0. We can use that point because it's really a quick thing to plug into our inequalities. The only time this won't work is if it is just a vertical or horizontal line. Then it gets a little fuzzy as to where you may want to shade. But otherwise, the origin's a good place to start. Let's look at another example. We have y is less than negative 3x plus 2, and y is greater than or equal to negative 1. So again, graph the top one with negative 3x plus 2. Our y-intercept is 2. and our slope is -3. That means we're going to go down 1, 2, 3 over 1, down 1, 2, and it goes off the graph over 1. This is a dashed line because it is just a less than symbol. And we're going to shade where the y values are less than the line. So like I was talking about a second ago, if you can't figure out where to shade, try the origin. If we plug the point 0, 0 in to this inequality, we would get 0 is less than -3 times 0 plus 2. So here, is it true that 0 is less than 0 plus 2, in other words, just 2? Yes, so that's the part that we're going to shade on. So we would shade on the part where the origin is at. Okay, we also need to graph the other line of y equals -1. That's a horizontal line. It is solid because there's the equal to, and this time we're going to be shaded where y is greater than -1, and that's everything above. So again, the overlapping region is where the solution is. So right there. Okay? And again, you could choose a test point in the solution region. And let's look at what happens if 0, 0 were plugged in. It turns out that it would work for both of these things. So, because it works for both, we have shaded the correct region. A system of inequalities may contain more than 2 inequalities. So if we were given this system, here there are 4. We're going to graph each of these things, and then we're going to classify the figure created by the solution region. Classifying here means what shape: rectangle, triangle, trapezoid, that kind of thing. So here we go. We need to graph the solid boundary line of x equals -2 and shade to the right of it. We're also going to graph the solid boundary line x equals 3 and shade to the left of it. We got that information based upon those 2 previous inequalities, which were x is greater than or equal to -2 and x is less than or equal to 3. Oops. Okay. Then we're also going to graph the solid boundary line y equals -x plus 1. And I know that this picture is super colorful now, but let me show you where that one is at. So the y-intercept is at +1 and our slope is at -1. So it turns out that this green line right there, that's our -x plus 1. And because we had y is greater than or equal to -x plus 1, it's a solid line we're shading above. And then we also have the solid boundary line of y equals 4, which is up here, this horizontal line going through the value of y equals 4. And we are going to be shading below it because we had y is less than or equal to 4. So now you can see that the overlapping region is this 4-sided figure. In other words, we've got a quadrilateral. So these 4 sides make up our shaded region. And that's it. I hope that will help clarify some questions you may have had on your homework, and I will see you next time in class. Bye.